Hey guys, welcome to today's class. Have fun.
Oxidation reduction reaction. Reaction involving oxidation and reduction are known as what? Redox reaction. What is oxidation? What is what? Reduction. Number one, we have the addition of oxygen. Oxidation is simply a reaction in which oxygen combine with what? Another substance. While reduction is a reaction in which oxygen is removed from a substance. For example 1, we discover that copper 2 oxide has been reduced to metallic copper. Removal of what? Oxygen. While hydrogen oxidized to become what? Water. Addition of what? Oxygen. So from our reaction, we discover that our copper 2 oxide is the what? Oxidizing agent, while hydrogen is the what? Reducing agent. Same goes for example 2. We have iron and water. Number 2, removal of hydrogen. Oxidation means the removal of hydrogen, while reduction means the what? Addition of hydrogen. The hydrogen sulfide, for my example, has been reduced to what? Yellow sulfur, since hydrogen has been removed from it. And the chlorine has been reduced to what? Hydrogen chloride. Hydrogen has been what? Added to it. Number 3, addition of what? Electronegative element. Electronegative element. Oxidation is the addition of electronegative elements and the removal of what? Electropositive elements. While reduction is the removal of electronegative elements and the addition of electropositive elements. Number 4, transfer of electron. Oxidation is a process involving the loss of what? Electron, while reduction is a process involving gaining of what? Electron. From our example, we discover that iron 2 oxide has a charge of what? 2 plus, which correspond to what? To give us what? Iron 3 oxide from our example. Move to the next subtopic, which is the use of oxidation number. The use of oxidation number. Oxidation number of an element is the electric charge that appears to have both in free and combined states, as determined by a set of rules. Free or combined states. A charge, it can be positive or what? Negative. Number 1 rule is all elements in the uncombined state has an oxidation number of what? 0. For example, magnesium is what? 0. Magnesium chloride 0, since it has what? No charge on it. Number 2, in a simple ion, the oxidation number has the same sign and value as the charge on the ion. E.g., we have zinc, it carries 2 positive, so the oxidation number of zinc is what? 2 positive. Number 3, the sum of oxidation number of the element in a compound is 0. Just like rule 1 that says uncombined states, the same goes for what? Compound. Number 4, the oxidation number of hydrogen is taken to be +1, except in hydride, where it is what? -1. The last row, the oxidation number of oxygen is -2, except in what? Peroxide, where it is what? -1. For example, calculate the oxidation number of chromium atom in potassium heptaoxodichromate chromate 6. So, solution, we have 2 moles of what? Potassium plus 2 moles of what? Chromium plus 7 moles of what? Oxygen. So you times it plus the what? Oxidation number. You get your what? Chromium. So plus 6 here is what? The oxidation number of what? Chromium atom in potassium heptaoxodichromate 6. How do we balance a redox reaction? There are two methods of balancing redox reaction. Number one, we have the half-cell reaction, and number two, we have the oxidation number reaction. Half-cell reaction method. We have some steps we are going to follow. Number one, write out the oxidizing agent and reducing agent and get what the product should be. Guess what the product will look like. Number two, make them indicate the same number of electrons produced and used. That means we balance the half-cell what? Equation. Number three, we now add the two half-cell equation to get the next what? Reaction. Let's take this example. Give a balanced equation for the reaction. Give a balanced equation for the reaction. Permanganate plus tin plus hydrogen will give us what? Manganese plus tin plus water. This is what? An unbalanced equation. We are supposed to balance the equation. But one thing you do is you split the equation to oxidation and what? Reduction reaction. From our equation, oxidation means lose of what? Electron. So our tin lose electron to become what? 4 positive. While reduction side, permanganate lose oxygen to become what? Manganese. We balance the half-cell equation. We balance it. For you to balance it, 8 in the front of hydrogen. In front of hydrogen, you make sure that your hydrogen is what? Equal. Your hydrogen in the reactant side is equal to the hydrogen in the what? Product side. Your oxygen in the reactant side, your manganese in the reactant side is equal to the manganese and what? Oxygen in the product side. From there, we move to our oxidation reaction. See that we have one thing, so they are balanced. Now we balance the half-cell equation with respect to electron. Respect to what? Electron. We now add the two half reaction together to get the next what? Reaction. The second method, the oxidation number method. We illustrate it using the method. Say number one, we assign oxidation number to each element using the rule stated earlier. That is the use of oxidation number. We ensure that the Conservation of hydrogen atom and what oxygen atom. We must ensure the conservation of hydrogen atom and what oxygen atom. From there, we're able to balance your equation. Solubility. Solubility is a means of comparing the extent to which different solutes can dissolve in a particular solvent at a definite what temperature. Although most substances are soluble in water, some are more soluble than others. That is, their solubility was differs. Solubility of A at 100 degrees centigrade will be different from solubility of B at 150 degrees centigrade. Determination of solubility. The solubility of a substance or a solute in a solvent at a particular temperature is the maximum amount of the solute in gram that will saturate 1 dm cube of the solvent at that temperature. So number one thing you do is you prepare a saturated solution of a given solute at that temperature. Take a known mass of the saturated solution, dry, and know the mass of the saturated solution so the temperature can be what? Calculated. What is a saturated solution? Saturated solution of a solute at a particular temperature is one which contains as much solute as it can dissolve at that temperature in the presence of undissolved solute particle. That means dissolved solute is equal in equilibrium to undissolved solute at a particular what temperature. At a particular temperature, while unsaturated solution, dissolved solute is not equal to what undissolved solute at a particular temperature. We also have supersaturated solution. Supersaturated solution contain one or more of the solute that it can normally hold at that temperature, and it is not stable. The excess solute will separate out if the solution is disturbed slightly. Calculation on solubility. 500 cm³ of a saturated solution of aluminum chloride contain 26.7 gram. Dissolve in it at 45 degrees centigrade. What is the solubility in mole per dm³ at this temperature? What's the first thing to do? Look for the molar mass of what? Of your compound. What is the compound there? We have what? Aluminum chloride. The molar mass of aluminum chloride is 133.5. Now from the question, we say 26.7 gram dissolve at what? 45 degrees centigrade. So to get your number of moles, you divide 26.7 gram by 133.5. We get our what? Number of mole, which is 0.2 mole. But we are looking for what? The solubility in mole per what? dm³. Now 1 dm³ is equal to 1000 cm³. From the question, we are given 500 cm³. If 500 cm³ of the solution is saturated by what? 0.2 moles of aluminum chloride, therefore 1000 cm³ which is also equal to 1 dm cube of the solution, will be saturated by what number of moles? So we represent it by what? X. You cross multiply, divide, times. Your X is what? 0.4 mole per dm cube. So the solubility at 45 degrees centigrade is what? 0.4 mole per dm cube.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.